Welcome to this video on the student t distribution and t of alpha over 2. This video will answer the following questions. What is the student t distribution? How is the student t distribution different from the normal distribution? How do you find alpha given the confidence level of a confidence interval? What is t of alpha over 2, and how do you find t of alpha over 2? Let's begin. What is the student t distribution? Until now, we have only used the normal curve to determine the relative distribution of values in a population. However, when we want to estimate a confidence interval or perform a hypothesis test on a mean and standard deviation problem, the z-test doesn't always work, specifically when sample sizes are small, n is less than 30, and the population standard deviation is unknown, which is virtually always the case in real-world situations. The normal curve does not do a good job of representing the shape of the probability distribution. Because sample sizes can be so small, the shape of the distribution begins to differ from that of the population as a whole. That is where the t-distribution steps in to help. Whereas a normal distribution describes a full population, t-distributions describe samples drawn from a full population. The t-distribution for each sample size is different, and the larger the sample, the more the distribution resembles a normal distribution. William Seeley-Gossett and the student t-distribution. The t-distribution was developed by William Seeley-Gossett, who originally published his work under the pseudonym Student. Gossett used this alias as his employer, Guinness Brewery in Dublin, Ireland, considered his work proprietary and did not want their trade secrets shared with competitors. Gossett worked with exceedingly small sample sizes, with n as small as 3 in some cases, as he endeavored to find the highest yielding varieties of barley. If Guinness Brewery sounds familiar, it may be because the only Guinness Brewery outside of Ireland is located right here in Catonsville, Maryland. At the time that Gossett developed his work on the t-table, he was convinced that his work was of little practical importance to anyone save a select few in fields similar to his own. How surprised he would be to find his work in virtually every statistics textbook on the market today. Carl Pearson recognized the importance of Gossett's table and helped to complete and perfect the values in the table, a gargantuan feat in a time when calculators were huge mechanical contraptions, not the electronic wonders we now have. Understanding the t-distribution. As we said before, the shape of the t-distribution changes depending on the sample size. T-distributions with sample sizes smaller than 30 have much fatter tails, as you can see from this green curve here. As n starts to approach 30, we can see that the curve looks much more like a normal curve. Now let's answer the question, what is alpha? Alpha is the area to the left and right of the middle portion of a confidence interval. Below, a 90% confidence level is illustrated on the t-distribution. The combined area in the two unshaded regions to the left and right of the shaded region is 10%, or 0.10. This is alpha. We can use the following equation to find alpha. Alpha equals 1 minus the confidence level. So in this case, since our confidence level is 90%, or 0.90, alpha is 1 minus 0.90, or 0.10. Historically, t-tables have been used to find the area under the curve. Let's take a closer look at the t-table that's being shown here. Notice that the header row lists common values of alpha. Also notice that there are two rows. There is a one-tail row and a two-tail row. If we are working with confidence intervals, remember we're always going to be using this two-tail row. The left column lists something titled DF. That stands for degrees of freedom and can be calculated by degrees of freedom equals n minus 1, where n is the sample size. Notice also that our confidence level is listed down here at the bottom for our convenience. So for example, if the area in two tails is 1 or 100%, that means we have 0% confidence. Notice that the table goes from 0 and then it lists 50, 60, 70, 80, 90, and it lists 95, 98, 99, 99.8, and 99. So again, for example, let's take a 95% confidence interval. If you have a 95% confidence interval, that means the area distributed among the two tails is 0.05, and the area in each tail is 0.025. Looking at this table, you might start to feel a little bit overwhelmed. The t-distribution and StatCrunch. Fortunately for us, today we use StatCrunch or similar software programs. In StatCrunch, there is a t-calculator similar to the normal calculator. Go to Stat, Calculators, T. Here is an example of the output you're going to see when you click on the t-calculator. Notice that in this calculator, there is an additional field labeled DF. Remember, this still stands for degrees of freedom and can be calculated by n-1, where n is the sample size. What is T of alpha over 2? In this image, we are given a 90% confidence level. What does that mean? Well, that means that 90% of the data lies in this red shaded region on the T curve. If 90% of the data lies in that shaded region, then what percent is left over? Well, 10% is left over and is divided evenly between the left and right tails of the distribution. The unshaded area collectively is referred to as alpha. So the area in the left unshaded region is half of alpha, or alpha over 2. Likewise, the area in the right unshaded region is also half of alpha, or alpha over 2. In this case, alpha is 10%, so each side is half of 10%, or 5%. The t-value that separates the bottom 5% of the data from the rest is about negative 2.53. The t-value that separates the top 5% of the data from the rest is positive 2.53. Notice these are the same value with different signs. Since we always want our margin of error to be positive, we always use the positive t-value in our calculations. That is where the notation t of alpha over 2 comes from. Lastly, it's important to notice and understand that randomly we selected degrees of freedom equals 3. So remember, for each sample size, depending on your n, you're going to have a different curve here, and you're going to obtain different t-values. I decided to demonstrate using an n or a sample size of 4, and 4 minus 1 is 3. Again, it's going to depend on your specific example. You should now be able to answer the following questions. What is the student t-distribution? How is the t-distribution different from the normal distribution? How do you find alpha given the confidence level of a confidence interval? What is t of alpha over 2? And how do you find t of alpha over 2?